Assalamualaikum warahmatullahi wabarakatuh. We're going to continue our lecture with the deep drawing process. We already covered the shearing process and also the bending operation. So in here, we're going to cover the deep or cup drawing and also the miscellaneous processes related to the sheet metal working. For the sheet metal working, okay, so the drawing process is where the sheet metal forming is performed to make cup shape, box shape, or other complex curve or hollow shape part. Okay, so in this sheet metal forming process, the sheet metal blank is positioned over die opening, and then it will be punched or pushed towards the die opening. Okay, so the product that usually use this process will be beverage cans, ammunition shells, automotive part panels, and many more. Okay, so this process also known as deep drawing. This is to distinguish it from the wire and bar drawing so that people will not get confused on the processes. So here is the schematic diagram for the deep drawing of cup. Okay, so if you can look here, this is the starting material with the diameter dB, which is the what we call the blank diameter. Okay, so here the sheet metal will be placed here. Okay, and it will be held by the blank holder. Okay, so when we put the punch in here, so it will go down through this die opening. Okay, so if you look into this product, so it will look like this one. Okay, so the cross sectional will look like this one, and the final product will look like this one. Okay, for the clearance in the drawing, it is calculated by using the equation C equal to 1.1 T. Okay, so this is for the clearance on the side of the punch and the die. Okay, so where T is the stock thickness. So in other words, clearance will be 10% greater than the stock thickness. So to know the feasibility of the drawing process, there is some tests that need to be calculated. Okay, so some of them are drawing ratio, reduction, and thickness to the diameter ratio. For the drawing ratio, which is defined as dr, okay, so most easily defined for cylindrical shape. If we want to calculate the dr value, it is equal to db over dp. db is the blank diameter, dp is the punch diameter. So to indicate the severity, it is given that in the drawing operation, the upper limit, meaning that the maximum that we can reach is dr is smaller or equal to 2.0. So for the reduction, r is calculated by db, which is the blank diameter, minus dp, the punch diameter, divided by the blank diameter. So the value for the r should be less than 0.5. The next one will be thickness to diameter ratio, which is T over dB. So thickness of the starting blank will be divided by the blank diameter. So the desirability for the thickness over dB ratio is supposed to be greater than 1%. Okay, so as T over dB decrease, there will be a tendency for the wrinkling of the blank will be increased also. In order to get a correct dimension and also the correct size of the product, blank size determination is very important. So some point that need to be taken seriously before performing the sheet metal working or the deep cup drawing. The first thing is for final dimension of the draw shape to be correct, the starting blank diameter dB must be right. Okay, so meaning that we have to calculate to get the dB, the right dB. Okay, so then solve for dB by setting starting sheet metal volume equal to the final product volume. So meaning that in the end, the blank volume, the starting blank volume need to be the same with the final product volume. And the third one is to facilitate calculation, assume negligible thinning of the part wall. Okay, so when we perform the operation. So the other shape that we can produce other than cylindrical cups are like the square or rectangular boxes, as in the sink. Okay, so as the example of the product. And then we have step cups. There are cones, cup with spherical rather than flat base, and then irregular curve form as in automotive body panels. Okay, so each of these shape will present in own unique technical problem in the drawing. Now, let us look into the other sheet metal forming that perform on the press. Okay, so it can be classified into two, which are the operation that perform with metal tooling. Another one is the operation that perform with the flexible rubber tooling. The first one is ironing. So what is ironing? It is a process where we want to thinning the wall of the cup and also elongate the wall. Okay, so if you look into the process here, this is the normal deep drawing, and then it does not stop here. It's going through the die on the bottom here, where the what we call the thickness of the sheet will be reduced, and but then the what we call the wall will be elongated. Okay, so this is the ironing process. Another process is called embossing. Okay, so embossing is when we create indentation in the sheet, so like the one that we see in this picture. So A is the picture for the punch and die that configure during the pressing process, and this is the final product that embossed with the rib. Okay, another process is Guerin process. So this Guerin process is called Guerin stamping. It is a manufacturing process used in the shape of the sheet metal. Okay, so this is one of the oldest and most basic production using the rubber pad forming processes. Okay, so if you look into this part, okay, this is the sheet metal working, and this is the form block. So there will be a rubbing pad over here, and then when we give the velocity and also the force over here, it will form the sheet metal according to the shape for the form block, like this one. Okay, so this is the before and after of the process. Among the advantages of the Guerin process will be it is low tooling cost. Okay, so what we need is just the form block and also the what we call the rubber pad. Okay, and then we just perform it using the force that we apply on the punch. Okay, so form block also can be made of wood, plastic, or other material that are very easy to shape. Okay, so like a pattern making in the casting process, something like that. Okay, so we can make it into the shape that we want, and then we can use it using this Guerin process. Okay, so the same rubber pad can be used with different form blocks, although we change the form block shape. Okay, so but rubber pad is the same rubber pad is still can be used in the operation. Okay, so the process is very attractive in small quantity production. For the dies of the sheet metal working, in most of the press working operation, it is performed with the conventional punch and die tooling. Okay, so if needed, there will be custom design for the particular part, and usually the stamping die is used as the term for the high production dies. So here are the component of the punch and die for a blanking operation. So let us look into the operation here. So if you can see here, this is a strip stock that will be moving. Okay, so it is moving every time the punch will punch the blank at this area. So this is where the blank will come out. Okay, so what needed in the punch and die component will be the press ram. Okay, so in order to give the force and also the velocity to the blanking operation. Okay, and then we do have the punch holder, punch and stripper. Okay, so this is on the top part together with the bushing and also the guide pin. Okay, so and then on the bottom part we do have the die. Okay, so the die in here, and then this is also the stop to make sure that the strip is not continuously moving. When it come to this stop, it will stop, and then the blanking will start. The ram will go down and the punch will punch the blank down. Okay, before it start moving again. And then over here we have the die holder and also the press base. And here is the common components for the stamping press. Okay, so this is for the typical mechanical draft stamping press. What we have here is the flywheel. Flywheel is used to what we call to move the ram up and down when we move the flywheel. And then we have the drive frames, both the plate and also the bed. Okay, so usually the stamping will happen at this area, both the plate. Okay, over here. For the stamping process, the power and drive system is usually used is mechanical press. Okay, so in this mechanical press, it will convert the rotation of the motor to linear motion of the ram. Okay, so meaning that there will be motor over here. Okay, so it will move the ram up and down over here. Okay, so this is where the high forces at bottom of the stroke will be given, and it is suited for blanking and also punching process. Another power and drive system is the hydraulic press. Usually it uses a large piston and cylinder to drive the ram. So if you can see here, this is the hydraulic system over here, and then this is the cylindrical drive of the ram. Okay, so compared to the mechanical time, it has longer ram and stroke. Okay, and this is suitable for the deep drawing process. Okay, so because it can go for a longer what we call stroke. Okay, so however, compared to the mechanical drive, it is slower, of course, because it is hydraulic. It takes time for the hydraulic system to take place. Okay, now let us look into other processes. Now let us look into the operation that are not performed on press. Okay, so there are several processes. For example, the stretch forming, roll bending and forming, spinning, and high energy rate forming process. Let us look into the first one, which is the stretch forming. So the sheet metal is stretched and then will be simultaneously bent to achieve the shape change. Okay, so if you look into this one, the sheet metal is what we call a clamp on the jaw here, and then the die will come here, and then it will stretch form it into the shape of the die. Okay, so this is how the stretch form is performed. The next one is the roll bending. So in this process, a large metal sheet will be in form of the plates. Okay, so it will be formed in the curved section using the ball here. For example, the ball is moving, and then we feed in the sheet metal into this part, and then the sheet metal will start to bend. Okay, so this is how the roll bending process is take place. The next process is roll forming. Okay, so if you look into this process, the first one is when the sheet is feeded in between the two roller. Okay, so then in the middle part here, it will start to create into the bending shape like this before it goes to the third step, where in the end it will create the shape of like this, like a cup, but a long strip. Okay, So that's the roll bond forming process. The next process we're looking into is spinning. So for the spinning process, where the metal forming process in which an axially symmetric part is gradually shaped over a rotating mandrel using the rounded tool or roller. Okay, so there are three types of spinning process, which are conventional spinning, shear spinning, and tube spinning. So this is the first one, which is the conventional spinning. So the setup of the what we call the process of the conventional spinning is like this one. This is a sheet metal. Okay, so it is going to be clamped here, and this is the mandrel. Okay, so this mandrel will keep rotating. Okay, and then the roller tool will start to shape and give pressure to the sheet metal here. Okay, and then in the end the sheet metal will follow the shape of the mandrel after finishing. Okay, so this is how the conventional spinning take place. The next process that we're going to look into is the high energy rate forming HERF. Okay, so for the HERF, the process is to form metal using large amount of energy over a very short time. Okay, so the HERF process included as explosive forming, hydraulic forming, and also electromagnetic forming. Explosive forming is a process where we use the explosive charge to form the sheet or metal into a die cavity. Okay, so the explosive charge causes a shock wave where the energy is transmitted to force part into cavity, and the application of this product usually involved with the large parts, typically in the aerospace industry. So here is the setup for the explosive forming. So if you look into the first one, so there will be explosive charge here. Okay, so this is the sheet where it is clamped on this die. Okay, so this is the die where this area is vacuum. Okay, so there will be vacuum line over here. Okay, so when the process of the explosive forming, there will be explosive over here. It will create the shock wave, and then it will cause this wave to push the metal into this area. Okay, so that in the end it will create the shape of the what we call the sheet metal according to the die that already designed. Okay, so this is how the explosive forming take place. Next process is electromagnetic forming. The sheet metal is deformed by the mechanical force, where the electromagnetic field will be induced in the bulk part by the energized coil. Okay, so presently it is the most widely used HERF process and usually used in the tubular part. Okay, so here is the setup for the electromagnetic forming. So if you can look into here, so this is the die and this is the coil that will transform the electromagnetic to this product. Okay, so to the part. Okay, so when the coil is placed inside the tubular part, then the electromagnetic forming will take place. Okay, so then the product will follow the die shape. Okay, so like this one. So that's the end of deep drawing process and also the end of the sheet metal working process topic. Okay, so thank you very much for listening. Assalamualaikum.